Hey, what's going on, guys? Again here. In this video we're gonna code a simple driver that would allow us to connect a fly swatter to a laptop to control the mouse. Okay, I'm just kidding. So we're gonna be using Python and OpenCV to control mouse pointer using the web camera. And you might be wondering that we're gonna be using this part of a fly swatter. Nope, we're gonna be using this part. And you see I have a light background and this part is dark. So this is gonna serve as the pointer. And before I actually start coding, I would like to demonstrate how this weird thing works. So I'll now close my webcam review because the script that we're supposed to be writing obviously relies on a web camera. So I will close this window, right click and click minimize, then try to close this one, and then I try to create a file on a desktop, believe it or not. And if I succeed, then we'll go for writing some code to make it possible for you guys to reproduce this weird experiment at home. So let me just close this window, and I need to sit down. Okay, you'll now understand why. So if I touch my head with this, you see like I can already move the mouse. Okay, so here are my hands. Oh, sorry, something has gone horribly wrong. Okay, sorry for this. I just need to make it always on top. Okay, so I need not to step in with my head because you see like it already makes the mouse moving. Okay, so we don't really want that, so I need to sit down a little bit. And now this fantastic device. So okay, here I step in, and you see like by the time I'm moving this upwards and downwards or to the sides, the mouse pointer actually is moving. It's on the right part of the screen. Okay, so just in order to avoid this going for ages, I'll put the pointer here. So here are my hands. Okay, and here we go. Now if I want to stop the pointer here, I need to make like boom. Okay, and now I need to right click here. Okay, and now I need to go. Now you see how useful this thing is. So now I need to go slightly downwards. Okay, and now we need to click minimize. Okay, and bingo. Okay, so now let's try to do the same with the above window. Okay, it's a bit laggy, but it works. Can you believe it? Okay, so now I want to right click and ban again, ban. Okay, ban. Ban, yeah. And now going slightly downwards and ban. Nope, not like this. Okay, ban. Okay, and now minimize this one as well. Ban. Okay, and now let's try to create a file. Okay, somewhere over there. It's just fine. So ban. Okay, and going down, create document, stop, and ban. Okay, slightly downwards. I lost it. Damn. Yeah, it's challenging. It's really challenging. Yeah, my second hand is here. No bullshit. Okay. Oh my god, left or right? And now downwards. Yes. Yeah! Okay. Yeah, I nearly broke my wall. Okay, and create ban. And we got our new document. Okay. So now let's open this new document in a code editor. Ban. Okay. Okay. And boom. Okay, guys. So I hope this is clear that it kind of works as a proof of concept. So if you're interested in coming up with this sort of weird script, then without further ado, let's actually start writing some code. So just a couple of words before we start coding. There are really lots of different tutorials covering this exact topic, and the implementations vary from simple to complicated, but in most cases they either use some specific background, okay, so the camera view is being adjusted at some point, or on the other hand, some object detection is being involved, but the object detection is completely kind of different topic, and potentially neural networks might be involved there, and that's a little bit too complicated for such a trivial task. So eventually I came up with my own implementation of this logic of controlling the mouse pointer using something moving in front of the camera. So this is original code, and I'll try to present it as simple as possible. So without further ado, let's actually start. And we'll start with importing OpenCV. So I can say import CV2. Then we need to open web camera stream. So webcam equals to cv2.video capture and 0 to reference the web camera. At the end, we need to close web camera stream, and I can say webcam dot release, and also want to do some cleanups. So I want to say cv2 dot destroy all windows at the end, and here we'll go for main loop, and I can say well true. And here I want to capture frame from web camera. So two variables. The first one I'll call it stream OK, which means that the stream is OK, and the second one is the frame on its own. So we can simply say webcam.read like this. And now let's say if webcam is available, in this case if stream okay, we can say we can actually show next frame in a window. So here I can say cv2.image_show, and let's call the window web mouse, just like our project. And I wanted to display the frame, and now the escape condition just to quit from this program, so if cv2 dot wait key, and I want to use escape, which has the code of 27, key code 27. So if we press escape, I want to break out of this loop. Okay, so I now need to close my web camera, for otherwise it's not going to be working. And let's open the terminal in the current working directory, and by typing python 3 webmouse.py, I really hope to see my face in the web camera just after fixing some bugs. Yeah, I just forgot bitwise end. Okay, brilliant. So here is the working window. I probably need to clean the camera slightly a bit. Just hold on a second, guys. Okay. Yeah, sorry for this. It's just hopefully the camera would be slightly bit better after. Not really, but okay, this is enough. And I press escape to get away from here. Okay. Now the next thing we need to come up with is edge detection. So it's done in several steps. So first we need to convert frame to grayscale. Okay. And I can say, let's say frame grayscale equals to cv2 dot convert color, and I'm using the frame as an input, and I want to convert to cv2 color bgr to gray. And if we now print, if we now display this black and white stuff, this black and white frame, my face should be in black and white, which and it is so good. So the next thing is we need to go for the edge detection. So detect edges, and in this case here I can create a variable frame edges, and I'm gonna be using cv2.canny algorithm, and I'm taking this frame grayscale as an input, and the appropriate Canny threshold that I've been using is 200, the lower bound, and the upper bound is 300. And if we now display our edges, it should be like negative. Yeah, so this is it. So it's like not really that many edges being displayed, so to reduce the noise. And now if we see our fantastic device, which is our fly swatter, here it is, you see the counters, but we use this part, and as you can see right over in here, you see like what a nice edges we have here. Okay, so now if I just go down a little bit, so we already have this edges, and this is exactly what we need. But a part of this, we can also make our edges slightly a bit more stable. So let's call it like smooth edges generally, and I'll apply delete and erode functions. So let's say frame edges equals cv2 dot delete, and using this frame edges and none here, and then cv2 dot erode and frame edges and none. Let's have a look at the output. Okay, so it might not be visually seen that it become better, it became better, but on practice this is actually worth it. So here is our pointer that we're supposed to be using, and that's kind of the idea. Okay, now the next step to consider, we need to detect contours. So by saying contours, well, contours and edges almost the same thing, but not really. So let me just demonstrate you this. So I need to create two variables. So contours would be storing the contours, and hierarchy like this. Hierarchy is also used just for different retrievals of the contours. So here I can say cv2 dot find contours, and I'm using this edges right over in here. And the next parameter to specify is the way how to retrieve the contours. So I'll use retrieve external. So this parameter allows us to get just the biggest contours, and this automatically reduces contour noise. So it's just what I've used. Okay, and then cv2 chain approximation none. Okay, and now we need to pick up the proper contours, but before that, let's just quickly draw the current existing contours. So I can simply say cv2 dot draw contours, and let's draw it to the frame, onto the frame, and we use the contours here. Then to draw all of them, I'll use -1, and then the color, let's make them green, and the thickness equals to 2, and let's also print the frame. So now it should be my face with green lines around. Okay, and here is the most essential contour we gonna be working with. But as you can see, we have lots of unnecessary contours, so the next thing to consider, we need to get rid of those we don't really want to work with. Okay, so I would be using the most simple possible, I believe the most simple possible way of filtering the contours. So I would be using the contour area as the threshold to distinguish between those contours we need and those we don't need. So let's loop over contours, and I can say for, let's say I in range, let's call it index, right? For index in range, the length of contours. Okay, and here we want to skip skip contours with small areas. So let's say if, and here I'm using the cv2 dot contour area. Okay, so I'm using this contours index by the index, every next contour we're traversing here. So in the case if it's greater than 12, so this is experimental value, which serves nicely for my lighting, for my colors of the background, literally to work nicely with my web camera. You might want to change this value so to make it work better for you. And yeah, and actually, yeah, before anything else, let's draw the colors, let's draw the contours again, but it would not draw that many at the moment. So cv2, draw contours, and frame contours. This time I want to only draw those contours that are here, so only indexed by the index, and the rest is the same. So like this. Let's have a look. Okay, so it's like it's much less contours here. Okay, and here is the main thing that we're interested in. So this is it. Okay. Okay. Now the next thing we want to consider is to extract the X and Y coordinates of the starting points of every single contour. So every contour is a list of, is not a list, it's, well, it's a NumPy array to be exact. So it's the set of coordinates like X, Y, X, Y, X, Y, and so on. So it starts somewhere and it ends somewhere. So at the moment I want to extract the starting points, so the starting coordinates for every single contour that we encounter right over in here. So let's say X is equal to contour and contour I, so the contour is I, the first one, and then like this and like this. So just to give you an idea why I need that many, so let's print the contours. Let's just print the current contour to give you an idea of what's happening here. Okay. Sorry, not I, but index. So like here is how the contours look like. But if we actually print the X and Y, then we will have the coordinates of the very starting point. So I hope it's clear. Okay, and now we want, so here we want to get first point in contour, get, let's say, starting point coordinates in the contour, and then we want to draw starting point in the frame. So I'm using cv2.circle, and we're going to be writing on frame. Here I use this X and Y values. Then the color, so let's first the radius, so let's make it 5. Okay, then the color, so let's make it 0, 0. Well, it's gonna be green, so let's make this one green. Okay, and the thickness would be, let's as the radius 5. Okay, and now it already should be displaying this dots. Okay guys, so this is what we have. Okay, and now here is the deal. So we don't really need that many. Okay, we only need those. So the reason why I was gonna sit them down lower, so up until this point, so I need to detect only those going upwards, and those going downwards are not important. So we'll now add another condition to display only these points where we enter the certain range of coordinates. So I can simply say if so this is like, let's say, get point only in specific area. We'll later on we'll draw the rectangles being responsible for these areas, but for now we can say if y is less than 200. Only in this case we want to go for all the stuff we're currently up with. Okay, like this, save, and here we go. So now if I just go down, okay, and here is the point. So now we just need to visually draw this entry point where our where detection occurs actually. So it's not happening here, but it starts happening here. So to make it a bit easier, we'll now draw the rectangles. We'll now draw the rectangles to distinguish the areas where we're supposed to be moving the mouse pointer, and also to rectangles to specify left and right mouse button. So would it be once we get in there, that means that we can like mimic the click. Okay. So yeah. So just to save your time, guys, I will paste this rectangle. So here we want to define, here we want to draw touchpad, and kinda left and right. Draw touchpad, left and right. Buttons, mouse buttons or touchpad buttons, that doesn't matter really. So we draw them to the frame, and here I already have the specified parameters. So let's have a look. Okay, let me just go slightly downwards. Okay, so now, yeah, you see, like as soon as we start going to this area, we already have this detection occurring, right? If we go outside, it doesn't. So here it does. So why this is happening? So it doesn't yet recognize left and right. So here is the reason. So we have the 200th threshold on the y coordinate, and here it is. Okay, and we also have this 200th for the height of our rectangle. Okay, so now we need to handle three cases. So the first thing we need to handle actually mouse movements. Then we want to handle left button click, and then we want to handle right button click. Okay, so now we need to take into account the coordinates like from left to right. So here is so here we have here is the touchpad. Okay, here we have the left button, and here we have the right button. So it starts 130 and ends up at 500. So we can say if our x is greater than 130 and if x is less than 500, in this case we can draw our circle. So before anything else, we need to make sure that the matter of detection only happens within the current given. Okay, so not okay, so the right edge, so nothing happens here, but it happens here. Okay, and nothing happens here, but it, yeah, okay, okay, good. So I'm sorry, so the next thing to consider, we need to provide the detection of the right button and the left button. So let's go for it. Okay, so the left button would be if and x is greater than 100 and x is less than 130. In this case, let's draw a circle, but this time it would be blue, just like the rectangle on its own. Okay, and for a right button, we need starting from 500 to 530, and I want to draw the red circle. Okay, here we go. So green, so here should be red. Okay, it's red here. Nope. For some reason here we have the blue. Okay, here we have green. Okay, so it's just poorly recognized. Okay guys, just hold on a sec, let me figure out what's going wrong with the recognition here. Okay guys, it seems like I just figured out what's wrong here. So in order to improve our the smoothness of detecting our fly swatter, we need to slightly smooth the edges. Say smooth edges, so I can say frame edges equals to, and I'm using cv2.delete edges and none, and here I will use cv2.erode and like this. And now it should be working a bit more stable. So let's check this out. Okay, so you see now it's more stable, so it's not blinking or something. So yeah, now this is really nice. So we have the red one, okay, we have the green one, and we have the blue one. Just don't touch the upper bound with my hand, the lower bound, I mean this one. Okay guys, so it's already seems to be quite pretty nice. Good. So yeah, I think now it's time to actually start moving our mouse. So yeah, let's go for mouse movements movements handling. So before anything else, I want to define global mouse coordinates. So I'll call them old x, and it would be equal to I'm taking the resolution of my screen and divided by 2, and old y equals to integer. You might have like whatever values here, they just need to be within the range of your screen resolution. 768 divided by 2. Okay. And by the way, we also need to import pyautogui as pg to be able to actually call this operating system level functions to move the mouse. So this is cross-platform package. It should be working on whatever operating system. Okay. And now right over in here, let's say move mouse pointer, and here I'm not going to be optimizing this code, so just to make it as clear as possible. So if x is greater than, well, actually before anything else, let's actually update global coordinates before I forgot that completely. So we need to say old x and old y equals to x and y. And now moving the pointer. So if x is greater than the old x, then we want to say pg dot move relative, and I'm using 5 pixels in a time. So like this, move relative. Okay, then if x is less than old x, then pg move relative -5 and 0. Now if y is greater than the old y, pg dot move relative 0, 5. And finally, if y is less than old y, -5. And if I did everything properly, it now should be capable of moving the pointer. I just need to, sorry guys, I see already it does move the pointer. Oh, sorry, it gets very laggy. So okay, going upwards, going sideways. Okay, yeah, this is kind of it. Remove. Okay, and I need to make sure that I can move this like this. Okay. Yeah, so just to make sure that I can move it. Okay. And to the other side. Yeah, the slower I move my fly swatter, the better it works. Yeah, okay, so that's kind of it. And the very last thing, we need to handle clicks. So in this case, we want to left click the mouse, and I can say pg.click. And in this case, we want to right click the mouse and pg.click and button equals to right. Okay guys, so now the moment of truth is about to come. So let me make it always on top. Let's put it somewhere here, and here we go. So I'll try to minimize the terminal window now. Okay, I'll try to minimize the terminal window. Bam. Okay, now let's go for right click. Bam, bam. Damn, bam. Okay. And now it's very handy. It doesn't recognize this part. You see, like, it doesn't recognize this part. It doesn't recognize, almost doesn't recognize my finger. Okay, and bam. And now we go to click. Okay, and now let's do the same. Don't click downwards. Okay, now let's move upside. Oh, bam. Okay, and right click. Oh, well, actually this is fine. This is fine because, yeah, I actually did already manage to, yeah, so let's move this somewhere. I did manage to minimize the window, which is good. So yeah, okay. No, I don't want to create new folder, please. Just want to get rid of this. Okay, and let's say if I want to open this new document, and double click. Okay guys, so I think this is good enough for, oh, what have I done? No, go down. Oh man, sorry. Yes, I just turned this off. Okay, so I think this is quite pretty good enough for a YouTube tutorial. So I'll definitely, like as always, this code would be available on GitHub, so try to play around. If you have any questions, feel free to answer them in the commentaries down below. This is it from my side. Thanks for watching. Until the next time, and take care.